I have a confession to make. Most of the machine learning models that I've trained over the years as an employee or as a consultant with my clients have been purely to analyze data. I know. You don't hear about that a lot on YouTube or LinkedIn or traditional media. But here's the thing though, long before data science was all the rage, people wanted to build an understanding of the processes that they cared about. And one of the most powerful techniques that they used to build this understanding of their processes were predictive models. So not surprisingly, one of the killer applications of Python and Excel is allowing professionals like you to build your own machine learning models from your data to derive new and interesting insights. For example, you might use a machine learning model to uncover a pattern in the data that nobody knew about before. Or, and by the way, this is also a lot more common, you build a machine learning model and you find patterns in the data that run counter to the prevailing wisdom in your organization or team. Yeah, that's real common. So in this video, I'm going to demonstrate how you can use Python and Excel to train a machine learning model, look at the machine learning model, and derive some insights from it. If you like what you see in this video, be sure to check the description below because there'll be some links to some free crash courses that I have on machine learning in Python, and you can learn a lot more about the techniques that I'll be covering in this video. So here we are in the example workbook for this video. And the first thing that I'm showing you here is the data. Now I'm going to talk a little bit about this data set, but what's actually more important than this specific data, this specific table of data, are the patterns that it represents, because that's what's super, super common when you use Python and Excel, especially if you're going to be using things like machine learning to derive new and powerful insights from your data. So this data set is US Census Bureau data. And essentially what's happening is that every row is an individual US citizen that provided data to the US Census Bureau. And what we can see is all the columns are various characteristics of these individual US citizens. For example, this US citizen is 20 years old, they have a racial designation of white, and a sex designation of female. But what makes this data set particularly interesting and why you might want to use something like Python and Excel to analyze it with machine learning is this column way over here. I have a column here that has some sort of outcome of interest. And in this particular case, it is a designation of income level, less than or equal to $50,000 US per year, or greater than $50,000 US dollars per year, which I'll call low income or high income respectively. And what we want to do is we want to take all of these other columns here and be able to find some sort of pattern in the data, some sort of association, some sort of accurate predictive relationship between all these other columns and this particular outcome of interest. Now, this is US Census Bureau data, but this general pattern exists everywhere. The rows could be patients if you work in healthcare. They could be customers if you work in marketing. They could be insurance claims if you work in the insurance industry. It doesn't really matter. The general idea is I have a bunch of columns of information, and then one of the columns happens to be some outcome of interest, and I want to be able to find the patterns of the other columns that predict accurately the outcome of interest. And this is a generic scenario that exists everywhere. Now, one of the things that you also want to think about is how complicated is the data. And let me give you an example. So we can see here we have lots of columns, but if I look at the occupation column, look at all the unique values of occupation. There's quite a few of them. And now if I go over here and I look at work class, I have more possibilities. And if I have marital status, I have all these different possibilities. And if I have relationship, I have all these possibilities. Now here's the thing. Think about all of the permutations, all the different combinations of these values that could potentially be mixed and matched to try and find the best predictive relationship with the outcome of interest. You could certainly do this by hand potentially, but it would take a really, really long time. And as your data set gets more complicated, you'll notice here that I've got about 15,000 rows. So it's a non-trivial data set. It's not huge, but it's not a toy data set either. As your data gets more complex, with the number of rows, the number of columns, the number of potential values, this gets harder and harder to do. And this is where machine learning comes into play. So this is a general pattern. If you have a lot of complexity in your data and you need to actually ferret out which combinations of things are actually highly associated, highly predictive of your outcome of interest, then machine learning with Python and Excel is a great way to analyze your data. So let's go ahead and see how we can do that using Python code. So I'm not going to make you watch me type out Python code. So I'm going to go ahead and copy and paste in code for each of these cells. All right, so first up, we need to load our data. We need to load our data out of that Excel table and into Python and Excel so we can do cool things with it like train a machine learning model. So how we do that is we need to use the py function. So equals py. And you can see here, this is the function that you use to create Python formulas if you have access to the Python and Excel public preview at the time of this recording. When I hit open parenthesis, notice that I switch over to Python editor mode for this particular cell. So I'm just going to go ahead and expand this a little bit here. And I'm going to paste my code in. And let's talk about what this code is doing. So first up, what we see here is the adult train is listed. But notice what it's listed as. It's listed as a parameter, as an argument to this Excel function. The Excel function is brand new with Python and Excel. It's your gateway. It's the ability for you to actually pull in data into Python and Excel from your Excel tables, from your Excel worksheets, and even from Power Query, which will be a subject of a future video on my channel here. And what I'm using the Excel function to do is say, hey, Python and Excel, go find the adult train table, give me all of the columns, and my table has headers in it, so I'm setting headers equals to true. By the way, with Python and Excel, this is a good practice. Use Excel tables, make sure your tables have headers, makes your life a lot easier. And what ends up happening is this function runs and then loads up the data into something which is known as a data frame. And in Python, a data frame is nothing more than how Python represents entire tables of data. So conceptually, think of it just like an Excel table. And what I'm doing is giving this new data frame in Python a name. And notice I'm using adult underscore train, and everything's lowercase. I could actually name this anything I want, but the coding convention in Python is to use underscores to separate words and use all lowercase. And this makes my code a little bit more self-documenting. So I loaded the adult train Excel table into a Python data frame called adult train. So I got one for one conceptual mapping. Good idea. Now, data frames have a lot of functionality. Just like data tables in Excel have lots of functionality. One of the things that they can do is they can provide you information about the table. So what I'm doing here is I'm calling an info function off of my data frame. Hey, adult train, give me your information. Tell me about yourself. So if I run this by hitting Control Enter, you can see here, Control Enter to commit or run your Python code. It'll take a second to run because Python and Excel actually runs in the Microsoft Cloud, not on your local machine. And what we can see here is a new pane. So let me make this a little bit easier to read here, called the diagnostics pane. And the diagnostic pane is just displaying all the information. So according to Pandas, which is the library that handles data tables in Python, I have a data table with 15,016 entries, which makes sense because the first row of the table in Excel was my headers. So technically that's not a row of data, so that's good. And you can see here all of the various columns that are labeled, that were loaded, and the names, and then their data types, all that sort of thing, which is really, really cool. Okay, I'm going to go ahead and close this down because I don't need this anymore. So I got my data frame loaded up. So the next thing that I need to do is take the columns that I want to use to build my model. Remember, I have that outcome of interest column. I don't use that to build my model. That's the thing that I learned how to predict. So I need to think about everything else. So let me show you some code to make this a lot more intuitive. Equals py, open parenthesis, and then I can paste in my code here. And what we can see here in this code is I'm going to create what's known as a Python list. It's a collection of values, essentially, which I'm calling all features. And these are the features, these are the predictors that I'm going to use to try and learn how to predict income level, whether somebody's low income or high income. So I'm going to use the columns age, education num, occupation, and hours per week. These are my predictors, these are my features. So my working hypothesis here is that older people with higher levels of education in certain occupation who work 40 hours per week might be highly associated with high income. In the US economy, not a bad assumption. So I'm just arbitrarily picking these particular columns out of my original data table. I could pick more, I could pick less, totally up to you. But for this demonstration, these are the four that I'm using: age, education, occupation, and hours per week. Now here's the thing. The occupation feature, as we saw, was a collection of text values. It was a categorical feature, a categorical column of various categories of various occupations. Python and Excel's machine learning algorithms, machine learning techniques can't work with string data directly. So what we have to do is transform it into a collection of binary columns, of binary indicators. And this will make more sense in a second when I show you what's going on here. But what I'm doing here in this code is transforming the occupation column from the string values to a series of columns that are binary indicators. Okay, and then of course I'm printing out my info again. So if I run this particular line of code, or excuse me, this code cell, this is what we get back. And what we can see here is that My new data frame here is a little bit different. Now remember, I originally selected 4 columns. These 4 columns: age, education, occupation, hours per week. But notice I actually have 17 columns now. And the reason for that is right here. You can see here that all the various individual possible values of occupation have now been transformed into their own binary indicator columns. So for example, if one person in the data set was an executive at a company, they would have a 1 for this particular column and zeros for all the rest. So that's what we need to do to make this work with Python and Excel. So let's go ahead and go back here. I'm going to go ahead and close my diagnostics pane down because I don't need that anymore. And now what we need to do is to prepare our labels, to prepare that column, the outcome of interest, because if you recall, that was also a collection of string values, less than or equal to 50K, greater than 50K. All right, equals PY, open parenthesis. Let's go ahead and make this a little bit bigger, paste the code in. And this code right here takes our label column of the adult train data frame. Remember, that's that label of less than or equal to 50K, greater than 50K, and then transforms it into numeric values. And if I run this code, we can see what happens here. Because notice here I'm doing some prints, which actually displays in the diagnostic pane here. And what we can see here is what's happened was the original string value, the original label, the original outcome of interest of less than or equal to 50K has been mapped to the value of 0, and greater than 50K has been mapped to the value of 1. So that's good because that's what we need. So let me close that down. We'll just move over here again. And now we're ready to train the model. Okay, equals PY, open parenthesis, paste my code in here. And let's talk about what's going on here with the code. What we're going to do here is use a particular type of machine learning technique known as a decision tree. And a decision tree is the single best place for you to start with machine learning if you've never done machine learning before. Decision trees are easy to understand. They're very interpretable for your business stakeholders, and all of the most powerful, most commonly used machine learning techniques are all based on decision trees. So this is a really, really super important technique for you to learn. And once again, I have some free crash courses, 2 of them in fact, on decision trees down below in the description of this particular video if you want to learn more about decision trees. So this is the code that actually trains my decision tree model. And what I'm doing here is I'm using my data frame here of predictors, and then my list of values, my zeros and ones for my outcomes of interest. And if I run this code, notice that all of these cells are running again over and over again from scratch. That's the default, and which is kind of annoying. So I like to switch that off, and this is how you do it. So you go up to the Formulas tab here in the ribbon. When you have Python preview enabled, you'll see this particular aspect. And what we want to do here is actually go all the way over to calculation options, and we want to go to manual. Notice this says automatic. This will run every one of your Python code cells every single time. All of them over and over and over again. Super annoying, so manual. Now that we have a decision tree classifier, which is our machine learning model, we can actually visualize it, which is what you typically want to do because that way it allows you to kind of understand what's going on in the model. So let's go ahead and do that. Equals PY, open, cut and paste. I'm going to close down the diagnostics pane here. And here's the code for visualizing a tree. There's a function in one of the Python libraries that you get with Python and Excel called plot tree. And what we see here is I'm setting the figure size, the size of the visualization to be 12 inches by 12 inches. And then I actually create the plot tree. And what I can see right now, I've got a bug here. So I'm going to go ahead and fix that real quick. They recently changed something in Python, so I'm having to do this here real quick to make sure that it all works. And then when I run this, notice that only that particular cell was running. Now, if I'd like to see the image, one of the easiest ways to do this is to highlight the cell, where it says image right here, and I can go ahead and switch this output type from Python object to Excel value. And then this will rerun the cell, but what I'll get back is a little image right here. Now, what I can do is I can make this image a lot bigger by just expanding the size of the cell here. And let me hide this. And here we go. There is our machine learning model. This is a decision tree. And notice what it's doing here. It's saying, okay, look, at the very top, it's looking at each individual age and it's learned a rule that says, look, if you're less than or equal to 29.5 years of age, so effectively if you're less than 30 years old, you go down this side of the tree. And it says right here, if you're less than 30, I'm going to go ahead and predict that you make less than or equal to 50K. So if you're less than 30, you're a low income earner. And now this model Might be good, might not be good, but this is what the model is telling us. This is what it's learned, a pattern in the data that it's learned for prediction. And the next step, it says, okay, look, if you're 30 or over and your education level is below 13, so in the United States, that would be essentially below college, so high school diploma or lower, then you go down this side of the tree. And then we say, hey, is your education also less than 10th grade in the United States? So that would be less than a high school education. Then we predict low income. Otherwise, we predict high income. And then otherwise, we predict high income. Now, again, this is a very simple tree. What it's telling you is these are the features that actually matter. Age and education, out of those 4 that we picked, occupation isn't anywhere in the machine learning model. That's super interesting, right? Because you figured occupation would be important. You think hours per week would be important. But no, that's not what the model's showing. But let's go ahead and take a look and say, look, this is a pretty simple machine learning model. Is it any good? So let's evaluate it. And the way we do that is we use something called a confusion matrix. So let me show you what that looks like. Equals py, open parenthesis, get a bigger cell here, paste the code. I won't drain this code. You can go ahead and pause the video if you'd like to look at it. What we really want to do is see the visual. So we're going to go ahead and run that. And notice once again that we get back an image. But what we would really like to do is actually make this an Excel value. And then we actually get the raw image. And once again, we can just make this bigger so we can see what's going on here. And there are other options as well for making these images pop a little bit bigger, but this is what I'm going to do in this video. So here's our confusion matrix. Along the y-axis here, we actually have our outcomes of interest from the original data set. This is known as the true label or the ground truth. And then here are the predicted labels. So not surprisingly, these yellow squares are the predictions that are correct. So the label predicted was 50K, greater than 50K, or a high income earner, when in fact the real label in the original data set was also a high income earner. So this is correct, this is correct. And these guys, these purple guys are wrong. And this is super interesting because it gives you an indication of not only how good is your model overall, but also how good is it in particular scenarios. And what we can do is we can use these numbers here to do some quick calculations to get some accuracy scores. So let me show you how to do that. Okay, let's scroll up here a little bit. Equals py, open parenthesis, make that a little bit bigger, paste my code in. And what we can see here are just the numbers that I pulled from the confusion matrix. So the correct predictions were those yellow squares. These are the 2 numbers. And then all predictions happen to be the sum of all the squares, right? Which would be around 15,016. Not around, is exactly 15,016 when you add these up. And then what I can do is I can say, look, accuracy is simply the count of all the predictions that I got correct over all of the predictions. And that's what this line of code does here. It calculates the correct predictions all up. But then I can also use the numbers from the confusion matrix to actually calculate low income accuracy and high income accuracy. So let me just run this because then looking at the numbers vis-a-vis the confusion matrix makes things a lot more clear. Okay, so I'm going to scroll up. And what we can see here in the diagnostics pane is overall accuracy is 70.7%, low income accuracy is 70.95%, and high income accuracy is 70.46%. So let's go back up to our confusion matrix here. So this first number is the accuracy for all of the things. These 2 yellow added together, divided by all 4 of these squares added together. Low income accuracy is just this particular row. So it's this value divided by this value plus this value. For only the values that are actually less than or equal to 50K, for only the rows that are low income earners, what was my prediction accuracy? And you can see here it's a little bit higher, about 71%. We can also see for high income accuracy, it's this row. So this value divided by this value plus this value. What's my accuracy only considering the high income earners? And you can see it's actually a little bit lower. So this is how you can understand what's going on with your model. Overall, it's about 71% accurate, which is not awesome. It's not terrible, but it's not awesome. And then you can see it's a little bit more accurate with low income earners than it is with high income earners. So if you decide to refine this model by adding in more columns, more features, you'd want to keep track of all this stuff to see how do these things change. There you have it, how you can train a machine learning model using Python and Excel and interpret it to possibly derive new and interesting insights. I've created this video to demonstrate the full potential, the true potential of Python and Excel. And that being said, I have to be honest, Python and Excel is not for every Excel user. It's really designed for Excel users that want to be able to differentiate themselves. Maybe somebody like you'd like to differentiate yourself at work with powerful data analysis techniques that just aren't possible with out-of-the-box Excel, no matter how hard you try. So if you like this video, if you like this content, I'm going to create 2 more videos next on my YouTube channel that further demonstrate how you can use more advanced analytics techniques to possibly derive insights that delight your stakeholders. And when those videos are ready, they'll show up right here as tiles. But until then, I'm going to go ahead and just pop up a couple of other videos about Python and Excel on my channel that you might find interesting. Until next time, please stay healthy, and I wish you very happy data sleuthing.